So continuing on applications of the fundamental theorem of calculus, if C of T is the concentration of the product of a chemical reaction, the concentration, then the rate of reaction is derivative. Rate is always the derivative. Okay. So integral from T1 to T2, time T1 to time T2 of the rate is concentration at time T2 minus concentration at time T1. So what is the integral give me? It gives me the change of concentration of C from time T1 to T2. Change, that's why the difference. Another example, if the mass of a rod measured from left hand point to a point X is mass of X, then the linear density is derivative of mass. Okay, this is rho, RHO. Okay, rho. So integral of rho x. So integral of derivative is nothing but mass at B minus mass at A. That is the mass of the segment of the rod that lies between A and B. Okay, this is also second part of the fundamental theorem of calculus. Now likewise, another way of talking, rate growth of a population, rate of growth, that is dn by dt. N represents number of people. Then integral t1 to t2 dn by dt. So integral of derivative is the difference in the values. N of t2 minus n of t1. What does this mean? This is the net change in population during the time period from T1 to T2. The population increases when births happen and decreases when deaths occur. Net change takes into account both births and deaths. All right. If Cx is the cost of producing X units of a commodity, then the marginal cost is the derivative. So integral of the derivative is the difference in the cost. So integral from x1 to x2 c prime x dx is cx2 minus cx1. This is simply fundamental theorem of calculus. What does it say in English? The integral of the marginal cost is the increase in cost when production is increased from x1 units to x2 units. All right. Integral of the marginal cost is the increase in cost. Now, another way of looking at it's all applications, right, of our language of mathematics. When an object moves along a straight line with position st, then its velocity is given by derivative. Velocity is derivative of position. So integral of velocity is difference in the positions. So t1 to t2, integral t1 to t2 of v of t dt is s of t2 minus s of t1. It is the net change of position or displacement of the particle during the time period from t1 to t2. Now you have to understand the difference between displacement and distance. Okay, let's see. Displacement, if you can see, if that's the velocity, integral of velocity is the positive areas minus the negative area. That is the displacement. All right. Whereas distance, you take absolute value of the velocity. It's integral. In other words, for distance, I don't have a picture for it. Even the area, so when you take absolute value, even this part of the curve goes up. That's why everything is added. In a displacement, you could subtract if your velocity becomes negative for a certain period of time. All right. So keep in mind, displacement is different from distance. Displacement is integral of velocity. Distance is integral of absolute value of the velocity. Okay. If we want to calculate the distance, the object traveled during the time interval, we have to consider the intervals when Vt is greater or equal to 0, also the intervals when Vt is less than or equal to 0. So instead of using just velocity, you are taking absolute value of the velocity. That gives me distance. Okay, this picture is very useful to keep in mind. Okay, acceleration. What do we know about acceleration? It is derivative of velocity. So integral of acceleration is difference of the velocities. Okay, if you give it time limits. A particle moves along a line so that its velocity at time t is given by this. Find the displacement from 1 to 4 and find the distance during the same period. So what's the difference between displacement and distance? Displacement, you would take integral of just velocity. For distance, you would take absolute value of integral of the absolute value. So one at a time. Displacement, S4 minus 1, S1 is simply integral of velocity. It is a straightforward calculation. That's not a problem. What about distance? Well, you want to know where velocity is less than or equal to 0. Fortunately, this is a parabola. You can factor it, and now you know at -2 and at 3 you are 0. So what happens? It's less than or equal to 0 from on the interval 1 to 3 and greater or equal 0 from 3 to 4. Why am I looking at 1 to 3? Well, because the entire time period given to us is 1 to 4. So -2 is immaterial, but your negative, okay? So this tells me maybe a picture is in order, right? How does a parabola look like? This one opens up, okay? So, whoops. Okay. How does a parabola look like? An opening up parabola. It's either above or below or whatever. We know that it is going to intersect x-axis at 3 and -2. So somewhere here is -2. Somewhere here is 3. And our parabola is going to go down, hit the x-axis at 2 and come up, hit the x-axis again at 3. Okay. Well, but I am looking at time interval from 1 onwards. I don't care about 0, -1, negative, so on. My time begins at 1. So from 1 to 3, it is less equal 0. And after 3 onwards, it is greater equal 0. All right. So integral from 1 to 4 of the absolute value, you have to change the sign of velocity from 1 to 3, because if it's negative, negative of that will make it positive. 3 onwards, it's already positive. I don't have to change the sign. And that is important to know. Okay. So basically our integral changes 1 to 3 and 3 to 4. You have to split it. Okay. Where it is negative, you have to make a minus, additional negative to make the quantity positive. And that gives you, after that it's simple calculation to give you a certain distance. So distance requires absolute value. Displacement requires no absolute value. All right. So this completes all the theory for section 4.4. Next videos will cover problems. Until then, bye.